All right, so I am going to record the review. I don't normally record reviews, but since Sailor's not here, I'm going to record it because her mom said she will be watching for it. So everybody say hi, Sailor. Ready? Hi. Wait. On three. 1, 2, 3. Hi, Sailor. Okay. All right, there you go, Sailor. All right, let's draw that thing that we did yesterday. So what we're doing is we're just reviewing that last problem. We almost finished yesterday, okay? Kind of gave you hints on how to do it, so that should have been okay, but I thought might as well just go all the way here. Let's put that. Okay, so you got a rectangle. It's centered at the origin. We talked about that. Then we talked about some of these points up here. This was E, F, G, and H. And they gave you this point, didn't they? Negative AB. All right, so without looking at your notes or your homework, what's point F then? If this is negative AB, what is this? AB, correct, positive AB. And then what's G? 2? Right, it's A, negative B. And then H, negative A, negative B. Good. Everybody good with that? All right. Remember how to do that. Why? There you go. It's going to be on the test. That's correct. So that should be easy. I think, let me see. Yeah, that's its own problem. I thought it might be a two-part problem, but it's not. Then I asked you to find the midpoints and the slope. What does it say? The midpoint of EF? Well, that'd be easy, actually. If you had to find the midpoint of EF, that would be that point right there. Excuse me. So without really doing the midpoint formula, you should be able to find that point right there. What is that point right there? Because this is the midpoint. Remember, it's centered at the origin, right? So this right here is going to be the midpoint of EF. So where is this? Well, how far over do you go on the X? 0. And how far up do you go? B. All right? That's pretty easy. Agreed? Let's find the midpoint of all these. Let's find all these midpoints. This one right here. So what's that midpoint? 0, negative B. Good. What's this midpoint of FG right here? What is it? A0, correct. A0. And then, this is pretty easy. What's the midpoint of this one? Is it A? It's negative A. 0. All right, good. So now they ask you, what was the other thing? The slopes of HF. Well, what is HF? HF is a what of the rectangle? It's a diagonal. Very good. All right. And so it says find the slope of that diagonal. Everybody see that? All right. So from here to here. Well, it's rise over run, isn't it? So the slope of what? HF? You could just do rise over run. So let's do that. So you're going to rise this far, right? How far is that from here to here? 2b, correct. It's 2b. And then what's the, and it's positive, right? Because you're going up. So if I go this way, if I go from H to F, you go up 2b, and then you go over how far? 2a. Simplify that, though. So what's the slope? B over A. All right, so the slope of HF is B over A. What about the other one? Without even doing any math or rise over run, you should be able to figure out what the slope of the other one was.
2.
Because they're congruent to each other. Remember, on a rectangle, the diagonals are congruent to each other. So, yeah, but without even going through all that, you should just be able to look at that. If you know what this is, if this is B over A, what is this one? What's the only thing different about it? The slope's the same, but it's just negative, right? It's the other way. So this one would be negative B over A, right? You could go through the whole thing and do the rise over the run of this one, couldn't you? You could go up this way, but now what are you doing? You're going to the left, right? So that would be a negative 2A, and there's your negative B over A. Everybody good with that? Yeah. So what started off looking fairly complicated when we first did this actually turned out to be pretty easy. Would you think?
We do one more.
No, that's it. Because I'm just sticking with things that are going to be on the test. All right. Everybody good? All right, so now let's go through. That's number 19 and 20 on the test, by the way. All right, so I pretty much hand-delivered it to you. I'm just going to go through some of these. I almost said you just took a quiz on this, but this was my CP class. The CP class just took a quiz on 6.1 and 6.2. So I just finished talking about that. So if you go back to some of your quizzes, the quiz on 6.1 and 6.2, I don't know, do you happen to have it with you? Do you keep a folder with all your stuff in it? Or is it's in your locker? That's okay. We'll just go over it. So number 1 is the sum. I'm just going to kind of tell you what these problems are. And if we have time later, then maybe we'll do some more specific ones, okay? But I'll tell you the style of problem that they are, all right? And then you can go back and look and figure out all that stuff. And maybe we'll throw in, if there's equations you need to know, maybe we'll do that as well. All right, so the sum of the measures of an interior angle, or the interior, I should put the, that's right, interior angles of a convex polygon. It's supposed to be an O. Convex polygon. Do you remember that? What does that mean? It means you're trying to find out, you're trying to do what? The sum. What does the sum mean you do? Add up, okay, all the interior angles of a polygon, convex polygon. Okay, we rarely work with concave polygons, so basically every polygon we've worked with and done problems with have always been convex anyway, all right? So that shouldn't bother you. So how do I find the sum of all the angles? If I add up all the angles inside a polygon, there's a little formula, a little tiny formula. It's not that big. It's not that hard. What is it? That's it. It's n minus 2 times 180. Okay? What does the n represent? How many sides you have. That's right. So, I don't know, give me your favorite polygon. I don't know, do you have a favorite polygon? Pentagon? All right, pentagon. So if I wanted to find the sum of the interior angles of a pentagon, what would I do? Okay, how many sides does a pentagon have? 5. So I go 5 what? Minus 2 times 180. All right, put degrees because it is degrees. All right, so it's whatever 3 times 180 is. What's that, like 540 or something like that? Whatever that is, okay? Everybody got it? Now, number 2 is kind of the same. You're going to do some of the same things, but it asks you something more specific. It says find, remember this? Each measure, okay, of the interior angles of a what? Of a regular, I'm not going to write all that stuff down just for the sake of time, but you can. Okay, find each angle, all right, of a of the interior angles of a regular or whatever gon. All right, again, give me your favorite gon besides a pentagon. Hexagon. All right, so hexagon is how many sides? 6. So what do we do first? Yeah, we still do the same thing as we did on number 1. We go 6 minus 2 times 180, right? Now, what does that give us, though? That doesn't give us each angle. That gives us the what? The sum of all the angles. So if it's a regular polygon, what do I know about a regular polygon? It means all the sides are congruent and also what else? All the angles are congruent to each other, okay? So regular polygon doesn't mean just an ordinary polygon, okay? Regular, in this case, means all the sides are equal, all the angles are equal. So if I know what all the angles add up to be, and I know all the angles are exactly the same, how do I split it up? What do? Divide by how many angles I have, all right? So if it's 6 sides, how many angles are there going to be? 6 angles. So I divide by 6. So you just do the math and you get what you get, okay? All right. It's been a while since we've done those, but go back. Watch the YouTube videos, okay? I can't say that enough. I know you get tired of me saying that. I'm not doing it to promote my channel. I mean, look, only like 5 people watch my videos anyway, all right? So I don't care about the views. I want you to use it to your benefit, all right? So watch the videos, and I go through a big, long explanation. You don't have to listen to the whole long explanation. Skip through all that stuff. Get to the part where I actually do the problem, okay? Everybody got it? All right, so number 3 deals with an isosceles trapezoid. So number 3 is an isosceles trapezoid. Well, let's draw it so we know what it looks like, and let's talk about it. So an isosceles trapezoid looks something like this. I'm trying to get it as close as I can. It's pretty close. And maybe about right there. Does that look like those two sides are equal?
Yeah.
Close enough. Do you agree?
Just say it.
Yeah, exactly. You're exactly right. Now, are they equal to each other? Yes, they are. Why? Because I put little tick marks on there, right? So that means they're equal to each other. And if I told you that this and this were parallel, then what is this thing? With that information right there, what is this? An isosceles trapezoid. Exactly right. Right? So what do I know about an isosceles trapezoid? Well, it's given to you, right? So what if that was 5? What's this? That's 5, okay? What if this was 3x plus 2? Then what's this one? 3x plus 2. Or, you know what they're going to do, though, don't you? They're going to give you some, I don't know if this works out. I'm just making this stuff off the top of my head. All right, what if this was like 5x minus 3 or something like that? I don't know if that works out. Probably won't. Probably get a fraction or something, but that's okay. But what would I do with those if I wanted to find the length of each of the sides? Set them equal to each other, then do what? Solve for x, and then, no, there's no y. And then plug it back in, right? You plug it back in. Angela, look on your face. She looked at him, she, what? It's kind of the same look that I had too. All right, anyway. So you know the deal with that, right? So that's no big deal. All right, so I'm not going to give you any specifics on that. You can just leave it right there. All right, number 4 is a picture with an exterior angle. This is also a trapezoid. Should I give you real specifics on this? Yeah, this was on the quiz. So if you look at the quiz, this was basically the problem on the quiz. So that's what I would study if I were you. It might be different numbers, but the style of problem is the same. Do you remember this on a quiz?
Oh, yeah, the one with the right angles.
And what if I told you this was, I don't know, let's say 150 degrees, and I asked you to find... I didn't write that very well on the test. Shoot, I'm going to have to go back and change it because... Anyway, I put a letter down here. We'll call this A, B, C, D. On the test, I said solve for angle C, but I can't just say that, can I? Because I don't know if I'm talking about this angle right here or this angle right here. All right. So what if, we'll call this E. What if I said solve for angle BCE? BCE. Super easy. Super easy. Yeah, that's what I'm asking. And I told you, oh yeah, well, first of all, let's do this. Is this a trapezoid?
Oh, yeah. No, it's not.
Why?
Because it's not.
She's absolutely right. Why is it a trapezoid? Tell me why. How do you know they're parallel? I didn't write that they were parallel. Because what about the right angles? You're onto it. I'm just trying to get you to go all the way here.
Like if they both are going into the same line, they both form right angles, and they have to be parallel.
Okay, so this is how many degrees? How many degrees is that? They add up to what? So give me a good geometry word. They're what to each other then? They're supplementary, right? So if you have two lines cut by transversal and your consecutive interior angles, which they are, aren't they, are supplementary, then what's true about the two lines? They're parallel. That's the reason, okay? That's geometry, okay? That's proving stuff. We basically proved it, okay? So we're not doing official proofs in here, but that's the mindset on a proof, okay? So is this a trapezoid now? Absolutely, okay? Even though I didn't initially put those parallel lines, it is a trapezoid because these two angles right here. So look at this 150. So these two are parallel lines. This could also be a transversal, BC, agreed? So tell me what BCE is. You don't see it? Why?
Oh, yeah. Because two. I forget what the
Look. Look, if that's, see, now it looks a little easier, doesn't it? Okay, but this is the same thing, right? It just doesn't extend all the way through. That one doesn't extend all the way through, but it's the same exact thing, right? So if that's 150, what's this one? 150, why? Thank you. Alternate interior angles. We say that more than any of the other ones, don't we? It seems like alternate interior angles. Yeah, the alternate interior angles are equal to each other. So this would be what? 150. There's another way. What if I asked you, let's say we hadn't thought that one through just yet. But what if I asked you for this angle right here? From 180, right. So it's 180 what? Minus 150, what's that? It's 30. So this would be 30, right? So if I ask for this angle, BCD, right? Everybody see that? It would be 30. If I asked you for BCE, it would be what? 150. Does it work? Even if I didn't know this, what if I knew that was 30? Could I find this angle right here? Sure, because it's a straight line, forms a straight line. This is 30, then this is what? It's also 150. So I could find this 150 two different ways, couldn't I? What's the easiest way? It's just to recognize that they're what? Alternate interior angles. You don't have to do any work. Boom, put your answer down, you're good to go. I wouldn't mark it wrong for not showing work because you can do that one without showing any work. Okay? All right, enough of that. That's number 4. Spent way too much time on that. Number 5 is a quadrilateral. It's just any old quadrilateral. It's not a trapezoid. It's not a parallelogram or anything like that. It's just a four-sided figure. That's all it is. Let's go like this. Let's go like this. All right? So there's a four-sided figure. Tell me something about all the angles. Oh. My one free period today, and I got a sub for a middle school class. That just ruined my whole day. I don't even know. It's Miss Larson's class, so I don't know. At least it's a math class. No, it's a 4th period. And I got a quiz I got to grade that period. Ugh. Okay, sorry. I don't know. Depends on what she gives me. I tell you what, when I sub for a teacher, the best thing is if I could teach something, because just giving them an assignment and just saying do it, it's almost impossible. So I hope I can teach something. I'll probably try. All right, well, I guess that other class isn't going to get their quiz back today. And I'm always pretty good. Aren't I always good about giving your quizzes and tests back the very next day? All right, anyway, so what are we going to do? I'm not going to go through the specifics here, but what's true about this angle? I'm going to put one arc. Doesn't mean they're all equal to each other, okay? But what's true about all these angles right there? What do? They add up to 360, exactly right. So what do you think they're going to do? What do you think they're going to put on this? This is on a quiz, all right? It's not anything new you haven't seen before. So what are they going to do with this? They're going to make, put x's in here, right? 2x, 1x, 3x plus 2, blah, blah, blah. So what are you going to do with all those angles? Add them up, set them equal to 360, then you're going to solve for x, then you're going to plug it back in, okay? Because they do ask for a specific angle, okay? Everybody good? All right, enough of that. Number 6 and 7 are all from the same picture, and we are dealing with a parallelogram this time. So 6 and 7, I'm just going to draw a parallelogram for you. And we're going to talk about it a little bit just to refresh your memory. But your memory should be pretty refreshed because We've been doing these lately, haven't we? Yeah, well, it doesn't look exactly like this, but it doesn't matter. I don't have to give it to you exactly. What are these things I'm drawing right now? Diagonals. Okay. So what if you had something like this? They tell you it's a parallelogram, okay? So you don't have to figure it out. They tell you it's a parallelogram. So what do you know about stuff here? Let's do this. Let's go A, B, C, D, and E, okay? Let's figure out everything we know about a parallelogram. What's true about A, B, and DC? They're parallel to each other, right? Because of definition. Very good. All right, so those are parallel, and you got these are parallel as well. Okay? What do you know about the length of AB and DC? They're equal to each other. That's right. They're congruent. So that one and that one are equal. And what else is congruent? AD and BC. Good. Let's not go to angles just yet. Let's talk about the diagonals. What do the diagonals do on a parallelogram? What do they do? No, they're not congruent. Not on a general parallelogram. On a rectangle, right? We just finished talking about that, the first example we did. Parallelograms of a rectangle are congruent to each other, but are the diagonals of any parallelogram congruent to each other? No, but they bisect each other, exactly right. Okay, I'll just tell you what, let's do this in a different color, because I don't want to have to put like 15 tick marks for each little thing here. So this one and this one are equal, and this one and this one are equal. Okay, good. Anything else we know about the lengths of anything? Nope, I can't think of anything else. Can you? No, let's talk angles. What do we know about the angles? Let's see. Actually, on 6 and 7, I don't ask you anything about the angles, but let's talk about it anyway. All right? What do I know about the angles? What do I know about angle A? Tell me a couple things. There's two things that I know, well, maybe three things, I guess, but they're the same thing. What do I know about angle A? Tell me something that I know about big angle A. Very good. It's equal to angle C, okay, because the opposite angles are equal to each other or congruent to each other. What about A and D? What's the relationship between A and D? They are consecutive interior angles. That is true. But what does that tell me about, like, if they're equal or they add up to something or whatever? Give me something. Be more specific than just saying they're consecutive interior angles. And you are right. They are. Absolutely are. But I do have parallel lines cut by a transversal. What's true about consecutive interior angles? They're what? They're supplementary. That's right. So A and D are supplementary. So A and D add up to 180. Okay. So if angle D's got two arcs, what else has two arcs? Angle what? Angle B. Because they're opposite each other. Big angle B. Okay. Everybody with me? So A and B are what? Give me one word. Supplementary. B and C are, come on, everybody play along. Angela's the only one answering. B and C are supplementary. D and C are supplementary. And then we already said A and D are supplementary. Everybody got it? A and C are congruent. D and B are congruent. Good. All right. Do we know anything about, like, the angle being bisect or anything like that? Nope, not on a regular parallelogram. Everybody got it? Okay. That's 6 and 7. So, and you know what they're going to do. Again, they're going to, like, 2x plus 4, 3x minus 2, whatever, right? You set them equal, solve for x, plug it back in, blah, 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 right? Same old routine, right? We do that. It seems like we do that all year, don't we? 8 and 9 are kind of like that, except they don't tell you that it's a parallelogram. What do you think they do? They say solve for x and y, or solve for a and b, to ensure that it's a what? Parallelogram. But the math is the same exact thing. They don't tell you it's a parallelogram to begin with, but they say what must be true. Let's go back to this one. Let's say they don't tell you that it's a parallelogram, okay? What must be true about this side and this side in order to make it into a parallelogram? They must be true. They must be equal, right? And they also must be parallel to each other, okay? What must be true about AD and BC in order to say that it's a parallelogram? Well, these two have got to be equal and they've got to be parallel to each other, okay? We've talked about the difference between that. It's a subtle difference, but it's a difference, okay? So 8 and 9 is basically like 6 and 7, except they just don't tell you it's a parallelogram to begin with. They tell you some stuff, and they say what must A equal and what must B equal in order to make it a parallelogram. Everybody got that? And I'm looking at it. It looks like on number 9, and I'm not going to do this because of time, but on number 9, it looks like you're going to have to do some maybe substitution or elimination to solve for x and y. Okay? We've done that before. Go back to it. I think, is it 6-3? I can't remember what lesson it is when we did the substitution or elimination. But go back to it, right? Just scan through it. Go to the YouTube, just scan through it. When you see the one where we did substitution and elimination, it might have even been 6-2. I think it might have been where we showed you how to do substitution elimination, all right? So make sure that you see that. All right, let's keep going. Let's turn this back into white. So let's talk about numbers 10 and 11 are the same picture. And it's a rectangle, all right? And we've kind of discussed already. Oops, I don't want that. I want this. There we go. All right, let's go through real quick. What do we know about a rectangle? Well, all the what? Yeah, let's do that first, okay? All the angles are equal to each other, but more specifically, they're what? They're right angles, okay? They're 90 degrees, okay? So we know that about a rectangle. What do you know about the opposite sides? Well, it's a parallelogram, right? So anything that's true about a parallelogram is true about a rectangle. So the opposite sides are equal, the opposite sides are parallel, all that kind of stuff. The consecutive interior, right, sides are supplementary, the opposite angles are equal to each other, all that good stuff, all right? What's the one thing that's a little bit different on a rectangle compared to a regular parallelogram? We kind of alluded to it, not alluded to it, we told you straight up just a few minutes ago about the diagonals. What's the difference between the diagonals of a rectangle compared to the diagonals of an ordinary parallelogram? They're congruent to each other, exactly right, okay? So again, just make it easy as I can. We'll call it ABCD again. All right. So AC must equal what? DB. And we know it's a parallelogram, so we already said that the diagonals do what on a parallelogram? They bisect each other. So what is true about AE and EC? They're equal to each other. And they're also equal to what? DE and EB. All four of those little segments right there are equal to each other. They're congruent to each other. Everybody see that? Right? Because they're equal to each other to begin with, right? AC and DB. And if you split two equal things, both of them in half, well, what you split in half are going to be equal to each other as well. Yeah? Sure. All right, so know about that. That's all I'm going to say about that. 12 and 13. Rhombus. So what do we know about a rhombus? Let's slant this, because usually they're kind of slanted looking, aren't they? Let's scooch this up. Does it look like all four sides are equal? Yeah, that's pretty close. All right. Guess what I'm calling it? Might as well, okay? Just make it easy. I guess I could think of different letters. All right, what do you know about a rhombus? What's different about a rhombus? Now, it is a parallelogram, okay? But what's different about a rhombus compared to a parallelogram? All the sides are equal to each other, exactly right. Does that make it a square? No. But is a square a rhombus? Absolutely. Is every rhombus a square? No. Here's a rhombus. It's not a square, right? So there you go. So you know that. That's pretty easy. What else are we going to throw in here? Somewhat. Yes. Throw in some diagonals. So there's that. Are the diagonals congruent to each other? No, they're not congruent to each other because it's not a rectangle. Okay, they're only congruent when it's a rectangle. Right? But they do bisect each other. Why? Because a rhombus is a parallelogram. Okay? But they do something a little different. What do? They're perpendicular. Very good. All right? So those diagonals are perpendicular to each other, okay? They're not on a rectangle. They're not on a regular, normal, everyday parallelogram. They're only perpendicular when it's a rhombus. Everybody good? All right. And I'll ask you some questions about that. Put an angle in here somewhere, and you got to find a missing angle and blah, 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 right? If I told you one of the angles Like if I said that this was, I don't know, 60 degrees, right? And I ask you to find this angle right here. That would be easy, wouldn't it? What would you do? I would go 90 minus 60, exactly right. Now a lot of people would say, oh, go 180 or add these two up and take it away from 180. But this is a 90 anyway, right? So what's 180 minus 90? It's 90. So just go 90 minus 60, which is what? 30, okay? I don't know if I'll ask you that specific angle or not, but, I could ask you any of those angles. Everybody good? Okay, enough of that. What was that, 10 and 11? Nope, that was 12 and 13. I didn't write 12 and 13, but that's what that was. All right, so let's do 14 and 15. We're almost there because we've already done 19 and 20, right? So 14 and 15 go together, and you have a trapezoid. It's not an isosceles trapezoid. So let's talk about this and the angles. We may have already covered this. There we go. So here's a trapezoid. Again, it's not isosceles, but you do know it's a trapezoid. They tell you right off the bat that it's a trapezoid. So that means that these two are parallel to each other, all right? And they give you some angles, all right? Again, 3x plus 2, 5x minus 7, or whatever, okay? And they give you some angles, and you got to solve for whatever angle they ask you to solve for, okay? So let's just talk about this generally. What's true, and we've already mentioned this, but we'll mention it again since what's true about this angle and this angle right there? What do we know about them? They're supplementary, that's right. So this one and this one do what? Add up to 180. Are they equal to each other? No, the only way they'll be equal to each other if it was perpendicular, okay? So these are supplementary. So they're going to give like this 3x plus 2 and this 7x minus 4 or whatever. I don't know what numbers I put in there, okay? Well, I do. It's right in front of me, but I'm not going to tell you which numbers. So what do you do with them? You just add them up, set them equal to 180, right? Solve for x, plug it back in, whatever they ask you to solve for, boom, you're done. Everybody good? Same thing with this. This angle and this angle are supplementary as well. Does that mean this angle and this angle are equal? No, all right, because it's not isosceles. All right, good enough. 14 and 15, pretty easy. Here's another one, but this is a trapezoid with, I'll tell you what, I'm just going to draw it in here. So this is number 16. This doesn't double up. 14 and 15 looks like this. 16 is also a trapezoid. It's just a separate picture, but they do this. Oh, actually, I shouldn't have changed the colors. Right there. Put a dot right. Oh, let's try this one more time. Okay, right there. Click off of it. Got to click off of it. There you go. Then come over here. Click off of it. That looks like that was there. All right. So what did I do? I took great pains, okay, to figure out that. What is that point right there? That's the midpoint of this segment. What's this one? The midpoint of this. Okay, it's a leg. Remember the non-parallel sides are called the legs. What are the parallel sides called, by the way? Bases. All right, just so that you know that. So what do you think I'm going to do now? I'm going to connect what? The midpoints. That's right. So let's do that. Let's connect the midpoints. And there's something that we know about this. First of all, we know a name. What's the name of that thing? Midsegment. Very good, because it connects the midpoints. It's a segment that connects the midpoints. That's a good name for it, isn't it? Midsegment. All right. Now, we know a couple of things about this. It connects the midpoints, so we know that this and this are equal, and we know that this one and this one are equal. But we also know something. We know a relationship between the midsegment and this. Let's call this A. Let's call this B. We know the relationship between that right there. You remember? We haven't talked about this too much, but we did. We did. Divide by what? 2. Exactly right. So this one right here is what? What would I do if I put these numbers in here? A what? Plus B what? Divided by 2. That's how you find the midsegment. Easy as that. Okay? It's basically the average, right? If I took two things and I added them up divided by 2, I'm finding the average, aren't I? So really the midsegment is the average, if you want to think of it like that, between the two bases. All right? And obviously, what are they going to do? They're going to put some numbers in here. And on 16, they don't even put any x's and y's. All right? They just put regular numbers. Let's just pick a number. Pick a number for this one right here. 12. Okay? Pick a number down here. 6?
18.
Yeah, okay. 18 would be better. 6 wouldn't, because that's way longer than that one, right? So I wouldn't call this one 6. Let's call it something bigger than that. Let's go like 20. Let's just call it 20. All right. So what would the blue one be then? Just do it in your head really quick. Come on, do it in your head. 16. Good. 20 and 12 is what? 32. What's 32? What's half of 32? 16. All right. Everybody see it? So look, it's the average. So look, what's the distance between 16 and 12? It's 4, isn't it? What's the distance between 16 and 20? It's 4. Okay? All right, enough of that. One more thing. What's the one thing we haven't talked about yet? You don't know. We did parallelogram, we did rhombus, we didn't talk about a square. That's right. I put no squares on here. Wow, how about that? I should have found a way to fit a square on here, but I didn't. That's okay. What's the other thing? A kite. Very good. A kite. So let's draw a kite. And does that look about the same? What? Up like that? Like this? What? A little longer? You sure? That looks good, doesn't it? Look, I can test it. I could do this. Oh, look at that. It's dead on. So that was perfect. What are you talking about? All right. Here, I could do this too, just to make sure that I draw it properly, but I'm just wasting time. See, I could do that and then do what? Connect from there to there, and then connect from here to here. There's a kite. And on this problem on the test, I don't even use that middle part right there, okay? All right, A, B, C, D. A, B, C, D. All right. What do I know? I know it's a kite. They tell me this is a kite. All right. So what do I know about some of these things here? AB and AD for angles? What? Oh, sides. Okay. Yeah. AB and AD. That's correct. So the ones that are next to each other, they're the ones that are equal to each other, not the ones across from each other. All right. We've been doing that with all the parallelograms. This is the one where the sides that are across from each other or opposite each other, they are the ones that are not equal. Okay. All the other ones were always equal to each other, not with this. So, but what's true about BC and CD? They're equal to each other. Okay. Bless you. What else do we know?
AB equals AD.
It's right there. The tick marks are right here. I think that's all we know about the sides, though, isn't it? All right, so let's talk angles. Do we know anything about any of the angles? Okay, well, they got exactly one pair of opposite equal angles. Okay, and which one do you think they are? Yeah, just use one letter since there's no other letters. B and D, right. So let's use B and D. So those are equal to each other right there, okay? Everybody good? So what if I told you this angle and this angle? How could you find B and C? I'm not going to put any numbers in here. Let's just talk about it and think about it. This and this. I know this one. I know this one. So how do I find angle B? It's the same as D. That's right. Okay. That's not a hard. I was not trying to trick you. Okay. It was that easy. Yep. Now, how do I find C? Exactly right. So if I already know this, remember, I know this. I know A and I know D. That's what they give you. All right. We could make up some numbers and put them in there if we wanted to, but you would just add them up. Oops. And if I wanted to solve for this angle right here, I would just add up those three, take it away from 360, right, because it's a quadrilateral, and then that's what that angle is right there. We good? That's basically the test. 19 and 20 I didn't do because I did it at the beginning. All right. So 19 and 20 was that rectangle and all that kind of thing. Yeah, I'll take it. Are you ready to turn it in? Are you going to use it to study from or not? All right. If you're not going to study from it, I'll just take it. Okay. Be ready for the test tomorrow. Should be easy, but there's a lot of stuff to remember. Would you agree? There's a ton of stuff to remember. So go through it. Read through your notes. Flip through the videos. You don't have to watch every second of all the videos that I did for this chapter, but scan through it, okay? Hit some parts that you think are important. Sit there and watch it. Let it sink in, all right, so that you're completely ready for this thing tomorrow. I expect really good grades on this. This chapter, I think, was fairly easy. Do you?
Chapter 5 is easy.
You think it was? What was chapter 5? What did we talk about on that?
Yeah.
Oh, the ortho center and all that. Yeah, you guys did great on that one. I think this is actually even easier. There's probably more things to remember, but I think it's more intuitive. You know what? I've talked about intuitive, right? It just makes sense. You know what I mean? A lot of this stuff. It does. I mean, if you look at a parallelogram, look at the opposite side. They look like they're equal to each other, don't they? They look like they're parallel. That's what I mean by intuitive. Okay? What's that? That was 18. Well, 17 and 18. Yes, 17 and 18. All right.